Welcome to APEC. It's July 6, 2024, and I'm your moderator, Tim Ventura. I want to thank everybody for joining us on today's call, along with everybody watching us on YouTube. So today, Al Baur will discuss levitation and propulsion in electrostatic field. Nathan Innen discusses classical coupling of gravitation and electromagnetism. He's going to be talking about the Meissner effect also. Shiva Miyuchi will be discussing the experimental record of neoclassical interpretation. Jared Yates will be talking about arts parts and reported UFO crash recovery samples. And Gerald will be presenting on electromagnetic coils and transverse gravitational waves. So a couple of quick notes about what we've been up to, because this has been a crazy busy summer, and it's all in a good way. A couple of weeks back, I flew down to Florida and I did interviews and took photos with the Exodus team in Orlando. So that is Andrew Arigma and then Dr. Charles Bueller, and I did in depth with both of them. I was so excited. And then Mark graciously drove me up the coast. We went up together to Todd Desiato's lab, and we helped him get some stuff organized and in play. And then from there, we went up to Falcon Space. At Falcon Space, we had the opportunity to analyze arts parts, the reported UFO crash recovery material with Jared Yates. And Mark also put together, he has an amazing dynamic nuclear polarization setup. And so this, again, just tremendous, tremendous stuff. We also stopped up at Massachusetts to see everybody up there, and I got photos of the whole thing. So that is all online, and I will tell you guys about that later. So that is kind of what we've been up to. But let me give you quick updates before we begin. Today's event is on StreamYard. We're broadcasting through the Alt Propulsion YouTube channel. If you haven't subscribed to Alt Propulsion, please do so now. You can ask questions during this live cast using the live chat feature on the right-hand side of the page, and we will ask them to our presenters depending on time constraints and if we see them, because those questions kind of scroll up really fast. So we will give that a try. You can also view conference replays, details, and speaker info on our website at altpropulsion.com. That recently had a makeover, and I am going to be adding more to it as well. So definitely take a moment to visit altpropulsion.com. So I want to get started here. We are a little bit behind schedule. Let me apologize for that. I haven't used this computer in a month, and so it all of a sudden forgot the microphone and the camera and all the settings. Interesting how that works. So now that we are rolling for today, I want to bring on Al Baur, who's going to be talking about levitation and propulsion in electrostatic field. Al, welcome, sir.
Thank you.
And if it's okay, can I bring up, should I start you with this?
Yes.
Wonderful.
I will start with this.
Wonderful. Well, thank you so much for joining us today. What I will do is, again, about an hour to present. I'm going to take myself right out of the studio, and you take it away, sir. And let me know. There is a back and forth button for the slides if you put your mouse over it. If you need to switch slides, because I see a couple of videos, just let me know and I can put those up for you.
Okay. Okay. What I'm going to explain is about electrostatics. Electrostatics is a family of electromagnetics. And electromagnetics is the second strongest force in nature. One of the things that is related to electrostatics is that it is believed to be a very weak force, which I want to show that it's not. Okay, the electrostatic levitation started around 300 years ago when somebody put a young guy up on ropes and was charged with electricity and was able to move gold leaves. from that point on, a lot of things happened, but not in electrostatics. The main new things that happen in electrostatics is in electronics, especially in chips, making of ionic thrusters in space. What I'm going to do here is to show that it's possible to make levitation with a self-propulsion only by electrostatic field, which shouldn't be possible according to Earnshaw. And he showed this mathematical in 1842. Now, the reason why he came to this conclusion is that he didn't use ionization as part of his considerations, and this system can work without PID loop or other feedback systems. So I consider this an exception of the Earnshaw theorem and the new branch in electrostatics. This system is not able to work in vacuum. So the characteristics: no aerodynamics, no visual propulsion, can stand still, can move fast, self-level control is self-propulsion, self-stabilizing and auto-centering, and at low voltage, that means that it's low voltage is the voltage where the levitation stops or partially stops. It starts to react as an animal, wobbling and jumping. And when you have 4 ionizers, I call it a horse, and 1 ionizer, I call it chicken, because the behavior is like that. With the too high voltage, it acts as a Russian soldier marching in a Moscow parade. Now, this is the basic shape of the levitator. What do we have here? Here we have a large surface which looks to the upper plate, which is charged negative and is attracted. This will go to a point, and here you have ionization. This leaf is made from metal, and it should be conductive, but it's also possible to make from paper or other materials, but then you have to coat on the outside, you have to coat it with some aluminum foil or carbon that is electrical transport the current. So here we see I use negative in the upper plate. The body is attracted. If it would be a circle, it will be attracted totally to the upper plate. It will get the same charge as the upper plate, and it will move down, and the charge will change. It will start to be positive, and then it will go up and down. So it will be like the bells of, what's the name? The bells of, okay, bells of $100 bill. Okay, whatever. Yeah, forgot. Okay, the levitator is made from 14 micron aluminum, or non-conductive of non-conductive with a 0.5 millimeter material in the rim. So here in the rim I put or a PLA of 0.35 or a half millimeter of what's it called? Nylon wire. Okay. This is for to make it more robust. Okay. Okay. The force on the levitator. We have electrostatic force up, attraction, gravitational force down, and an ion wind that can, dependent on the way the point is directed, it will go up or will go sideways. Here I have a sample of trajectory. It's between 110 millimeter, and the width is about 60. What you see here below is the mirror. It can work on wood, it can work on water, it can work on everything except a plastic table. Here is an extreme example of what happens. We see here the corona, that is the attraction force, and here we see the ionization on the point. Okay, by turning the levitator in one direction, the attraction will be this direction and the ionization will be the other direction. And this is what moves the levitator in the opposite direction. Single levitation. Okay, it's possible to make a single levitation by putting a counterweight on the leaf, and then it will go to the opposite direction. Okay, here you have an example. This is the counterweight. If this is in the field, it will turn to the right and move to the right. Here I have a sample of chocolate paper. It will do the same, it will work. This is a chocolate paper which has really paper and aluminum foil. Okay, the weight is from LDPE foam, low density polyethylene, and this I call the chicken levitator. Here are other samples of chicken levitator. Here you see one with a 4 millimeter neon. This will light up when it moves inside the field. Now all of them are about 45 degrees. You can do it until 90 degrees. You can move it, and when it moves more, then it's not stable. This is what I call the horse. It's made from 4 leaves. And this, for example, this is straight, and this will not move, it will stay in the field. Here we have 2 leaves, and both are bent 22.5 degrees. And this will move. And here you see also a needle. What is convenient with LDPE, that you can push needles inside, which other materials it's more difficult. Okay, here you can see what happens. You see the levitator is hanging inside the field. So the corona is pulling on both sides, but ionization is pushing in one direction. Okay, now one of the things that influence is pressure, humidity, and temperature, of which humidity is the most strong influence. And I give you an example here. Let's say I have here on 60, humidity on 60, I have an input power of around 2 watt. Okay. Now at 65, it's already 4 watts. So from a difference of 5 in humidity, the power goes up twice. And the levitator that is with a weight of 65 millimeters, this will not work above 65 humidity. Okay, for larger levitators, the trajectory is also larger, and the sensitivity of the humidity is less. And the strongest influence on the strongest negative influence on the humidity is the trajectory, and not the levitator. The levitator, never mind if it's low humidity or high humidity, the amount of energy that he needs to levitate is nearly the same. Okay, between 48 and 53 is the lowest power consumption, but I believe that this should be more elegant, this line, but I didn't use the consideration of pressure and temperature, which didn't change that much in the time that I make these measurements. Okay, this is to show what happened with the voltage on the trajectory in relation to humidity. So for to make a levitation at low humidity, 10 kV is enough, but if you go to higher humidity, you need like 50. Lifting capacity. The maximum weight of a single levitator can lift depends primarily on the strength of the lifting force it generates and the surface area of the object upper face in parallel with the levitator plate. And if I want to have more upwards force, I need to make the upper part of the levitator larger, and which is possible through a little bit of bending. Okay. Okay, combining multi-levitators, the lifting capacity will be significant increase. Each levitator contributes in lifting force. Maybe I will show. I don't have. Okay. Always having objects. Okay. Okay. Here we have a comparing of weight to power. If I have a weight of 1 gram, and this means the best case, a low humidity, I have nearly a half watt, and basic levitator is 1. Okay, worst case, it will be 1.5 watt. If the weight is 4 gram, it will be 0.83 watt. Worst case, nearly 3. And the amount of basic levitators is 4. Now, this is related to scaling. In principle, it's we dealing with, when we scale, we work in 3 dimensions. But electrostatics is 2 dimensions. I'm not totally agree with that. I think it's 2.5, because electrostatics works also on the side. Okay, here I have calculated, if I want, for example, I want 1 kilogram, what will be needed? I need 450 watt. For 10 kilogram, I need 4,000. For 100, I need 45 kilowatt. This is an estimate, and I believe this could be true or better. This is a comparing of energy to 1 horse levitator. These are test results. And you see different sizes here. This is the height of the levitator, and it's a horse that has 4 collectors and 4 ionizers. The length is, let's take this one. This is a quarter meter height with a length of 400 millimeter, a weight of 10 grams, and the energy that is needed is 13 watt on a humidity of 60%. The input voltage on the low side, it's 8.5. The calculated output voltage in kilovolt is 70 kilovolts. And I want to explain this. This is not the real measured value, because the impedance of the whole system reduces the voltage on the trajectory. The trajectory will need to be 800 millimeters. Okay. So, for what is useful? First of all, this system is against shock and fire. And as far as I know, is the lowest cost for levitation with propulsion in compared to other systems. The low energy enables it to work with batteries. In education, it could make a strong motivation for young people to learn physics. Experimental devices for testing floating objects. So let's say you want to have a floating object and you want to see the influence on by sound or ultrasound or electromagnetics, high frequency. This is a good device in making experiments. And also the measurement effect include principle. Then there's games. I can show a game from 2 ghosts that are fighting together. And if in the moment that one touches the other one of them will die or will fall down. Inventing interesting and new levitators like UFOs and things like that. The most interesting thing that are working on this in this moment is medical. It has the ability to eliminate viruses and bacteria and allergies, and this is a byproduct. It was not intended, but when I made the experiments, 2 things happened. First of all, I'm a heavy smoker, and the lower part, so the grounded part of the trajectory got golden. But this is from the electrostatics that attracted the smoke and put it on the lower part of the trajectory. The second thing, my son has psoriasis, and he came one day and say, from the time that you make experiments, the psoriasis went down. So I'm looking for a company that's able to check the ability of the system to eliminate viruses and bacteria and all of different kind of things. Okay. So it cleans also the air. In smoking area, like when you are in an airport and you go in the smoking area, it smells terrible. It will be able to clean the air there. Okay, for sure. Okay. Okay, data. The largest that I tested was 250 millimeters height. The fastest speed recorded is 4 meters a second. The limitation is centripetal force, which is related to the diameter of the trajectory. It works without grounding plate on water, sand, wood table, plastic table needs grounding plate like aluminum foil or metal. The highest weight I tested was 6 grams. I think it was higher. Okay, minimal requirements. A good high voltage power supply between 10 and 50 kilovolt. The power supply that I used can go up to 100 kilovolt. A mini digital scale with a resolution of 0.01 gram. A good humidity meter, aluminum foil, nylon or PLA, LDP packing material, contact glue, 3D printed template for levitation. This is 3D printed and makes it faster to make the levitators. Okay. This is a short, simple explanation of electrostatic levitation. For more information, you can look on YouTube, WEPRC. And if you have questions, you can send me by email. Now, there is another thing that I like to discuss. It calls the critical disruptive voltage. It's the voltage that happens between charged objects, and it is used by engineers in high voltage transmission lines. And what is important to see here is not so much the value that comes out from this, but the different, the environment influences the critical disruptive voltage. So this is the voltage that you, in principle, get jumping of electricity. Okay, let's see, we have here the atmosphere, okay, temperature, T, and T is below. So if the T goes high, then the value here goes low. So in principle, if you work with high voltage, you want to have a cool environment. Atmospheric pressure, B. If this value goes lower, let's say vacuum, okay, then this value will go low. So that electricity jump over will go more critical. And so, okay, now the humidity is for some reason in high voltage transmission line, they keep 30 kilovolt per centimeter, so it's 3000 volt per millimeter, which in high humidity, it's more like 2000 volt millimeter. And I hope to adjust this formula more to my requirements in the future. Okay, now I'll show you a few videos, if I can. Tim, are you able to show some videos?
Yes, absolutely. So Al, why don't I put this, I'll take this one out. Let me put up that video. There we go.
Okay, here we have a controller, and I stop it for a moment. Okay. Okay, we have here a controller that is able to change the voltage, the current, and the power. It's possible to limit the voltage, to limit the current, and to limit the energy. It has also an oscilloscope inside. So this is very important if you want to see leakages, unwanted leakages, and the behavior of in general. Okay, the levitator that you see here, okay, it takes about 2 watts. This is 120 millimeters height and 200 millimeters width. Okay, so here you can see the values. And in the moment, it's working as a voltage control. Mostly I work in current control. So, okay. You can put the next video. Okay, this is a sample of what I want to use in measuring the influence on the surroundings. What you have here, the negative plate, and here this is grounded, but this is open. This is how you call it? Open. Here, what you get inside here, you get the ions pushed down, and they push air molecules down there through the well, this here, I don't know how you call this. Tim, what's the name?
So let me see. So you should have an emitter, and then you have your collector underneath, it looks like.
Yes, but it's not closed. It's open. It's wow. Russian. Okay, you know, okay, I forgot. Okay, whatever. Okay, next video.
Okay, and I think this is our final video that we have for you.
Yeah. It's only possible to upload the 3 videos. Okay, here you have a levitator with 2 leaves, and Below is a mirror. Okay.
Now, Al, is this connected to the track using a string?
No. The upper part is connected to a negative output. You see the white wire?
So it's just levitating then. There's no string holding this up?
No.
Oh, that's amazing.
You see it two dimensional, but if you see it in 3 dimensions, it's real magic. It's real magic.
Yeah, that's absolutely amazing. I thought that it was being suspended from a string, but
No.
amazing.
There are no tethers here. I hope I was able to explain how it works, because if you look, the 2 leaves are bent sidewards, so the ions push on the backside of it.
Well, and Al, if you're open to it, at the end of your presentation, if you're open to having people do replications of this, I think that this is straightforward enough. It looks like it's something that a lot of people could at least try and build themselves. It would be exciting to have experimenters try and do this.
I'm looking for somebody that can help me with writing a book of all that is related to this. In the whole process of years that I made this, I wrote a lot, but it has to be organized.
Okay. Well, and if you put some contact info, you may have it already in the end of your presentation. Why don't I go back to? Is that your final slide? No, you have more slides.
No, there's another one, but
okay.
There's a physical critical voltage. It's important for everybody that works with high voltage that this exists, and that if you look up on the internet, you will find different formulas, because there are things like the smoothness of the wires and things like that. So to make this a useful tool, it has to be adjusted to the situation of the equipment that I use. Okay. Here there are nice toys. They're all wireless except this one. Okay, this is a Franklin bell. It has an antenna, and it charges up the plate here. And on the other side, the plate is grounded with aluminum foil on the bottom. And this goes to left and right. This is electrostatic rotor. It's difficult to see here. This rotates by electrostatics. This is ionic rotor. This is different. So ions pushed this is from a bottle. Okay, this is pipe ball. Okay, here this is electrostatic swing. So you see here a circle, and there's also antenna here that receives the charge of the trajectory, and this starts to be negative. And when this comes up, this will be attracted and comes up and start to be also negative, and that will be pushed to the other side and comes here with discharge and moves up and down. Okay. Then I have an EMP detector. What happens is the system is in principle DC, but because the ionizer is inside the field, you get the AC component, and you can see this with the EMP detector. So this is electrostatic indicator. So you can see it's positive or negative. And this is the controller, which in principle is a buck controller. And there is an oscillator inside, which a B-class sinus generator. Okay. I want to see. Come. Presentation. Video. Come.
And it looks like that's your final slide. You're doing a calculation right now for us, right?
I have another video. I uploaded another video.
Oh, okay.
You see?
I think I do.
Okay. Now here you see a different levitator. It's made from two circles, and you can say that this is a simulation of the Tic-Tac cube, because the Tic-Tac cube had also this kind of strange things below. And this, you can see this is the pushing force by ions of this levitator. And as now it's totally free moving. Okay, that's all. I don't hear you, Tim.
Sorry. The fact that you're able to make it go in circles like that, and the other one, the fact that you're able to make it follow the track, is absolutely amazing. That is so cool.
It's yeah, and it works automatically. It's a part of the field. The field wants to keep everything inside and regulates it.
Yeah.
So I'm ready to hear questions.
Well, let me do this really quick. When this thing finishes playing, again, this is so cool. I love watching that video. So I'm gonna take the video out. Let me bring everybody in though. We need to give Mr. Al Baur, and let me see. We need to give Mr. Al Baur an enormous applause. Al, thank you so much. Thank you so much. Oh, and I missed Mark. Mark, I'm sorry about that. I was looking for you and I couldn't find the window.
Oh,
yeah,
no worries.
Al, thank you for presenting that. It was a great presentation, and when you put the videos up, I remember you sending those to me. It just blew me away. I was like, "Where's the string?" And then Jared was texting. He's like, "There's no string. It's floating." I'm like, "Whoa, okay." So, well, do you guys have any questions for Al?
I think we have a lot of questions.
Yeah.
So if I understand this correctly, you have the plate on top, the plate on bottom charged. That's where the energy is entering the system, right?
Yes and no. I used the lower plate is grounded, okay? And I use them because I want to make measurements, but it's not really needed. You can do it without with the ground plate. You can I can show you. It moves over water. It can move over a wooden table. The whole idea is that the levitator needs to get rid of his ions. As long as he gets rid of his ions, he will move and he will levitate. Okay, so it's possible to make it levitate without the ground plate. Okay.
Okay. Well, eventually, wouldn't you have a buildup of ions in the air to a point where they're kind of equalized and be less efficient without a ground plate?
Say again?
If you don't have a ground plate, wouldn't you eventually build up an amount of ions in the air that would make the craft less?
Yes. The current will go higher. Well, will be a little bit higher. But it works, and works stable.
How heavy can the samples be? Can the craft be?
Say again?
How heavy? How many grams can they be?
I didn't get it.
Oh, he's asking about weight. I think this is like lifters. I think these are very light, like milligram sized.
No. It's grams.
Oh.
Grams, yes. But I believe it's possible to go to the kilograms. Only it will be a large device. I will elevate the weight, but I'm limited in my place. Okay. But okay, very important. Let's say I have a levitator of 60 millimeters height, and I compare this to a 120 millimeter. So I make the same, but I make it twice the size. Okay. Then the weight goes up 4 times, but the power only twice. The power goes only up twice.
Okay. So this works better in small scale.
Well, I'm not sure about that. It's easier because you need lower voltage, but I'm not sure about it.
Wonderful. Well, does anybody else have questions for Al? Oh, Jared, go for it, sir.
So in that very last one where you had the tic-tac kind of thing with the "We Come in Peace" on the side, first off, I love your little artistic touches on that. I was laughing very hard. It was wonderful. I had a question though. On the center base there, you had foil around there. Was that foil causing any interaction on it, or because you had the other one floating around the track without anything to pull it around those corners?
You have in principle, you have 2 cylinders which are interconnected with low density polyethylene. Okay. But if you would put the polyethylene on the upper part, the attraction will be very high and it will go to the upper plate. So you need to not, if you want, I try to make it like a tic-tac. So by closing the upper part, and I didn't get it to work. I believe when it make it larger, one day I will succeed so to cover it totally with non-conductive material, okay? But it has to be lower than the conductive material. If not, the charge will be attracted too strong to the upper plate.
I do have one follow-up question as well. So taking this to the craft that we observe flying, those things, if they are having some kind of electric track like you have, that track has to be to the surface and like the ionosphere, right? It has to be really, really far away and really, really strong electric fields. Have you done any calculations for that to try to estimate how they're doing that Earth ionosphere waveguide lifting?
I contacted a person that's supposed to be a professional in the ionosphere. And I want to know which kind of voltages are there. And if there's information, I got the idea that there's very little knowledge about it. Okay. So I have no idea how to relate to this.
Thank you.
Okay.
Awesome. Yeah. Al, thank you so much. Thank you so much. It is truly a pleasure. Truly a pleasure. I mean, those videos just blew me away. I didn't realize that you could do so much just using ions. I mean, I used to work with lifters, but you know, we had tie downs, we had wires, we had all that stuff. You were doing so much without any of that apparatus that I used to need. So
I was going to ask. I came in a little bit late, and so I was noticing like the one that was on the track. There's like a black portion, and then there was the the foil portions. And is that a different material than the like for instance the one that was going around the track?
If I understand the question correctly, you asked me the connection between the levitators.
I'm just asking what kind of materials you're using. In other words, I'm just trying to figure out if the principles are the same as lifters, because it seems like the way in which it's just staying in one place instead of having a constant ion flow and something keeping it in one place. It seems as though there's some other effect that is going on there. And so I was just curious about the material. Like for instance, you had a black material with the two foil things that were the foil things were what were giving it the movement to the side, but then the black portion seemed to be what was holding it, what was making it stay in place underneath your whatever the apparatus was there. And so I figured those are two different materials, and I'm just curious what the black material is.
Okay, the black material, maybe you go back, Tim, to the
yeah, I can put this one.
Okay, you see here white. Okay, the connection between the two cylinders is white. This is packaging material, so low density polyethylene. Okay, it's also exists in black. It's the same. So
Okay.
it has no. It's an isolator.
You're just insulating plastic. Okay, well, we are just about at the top of the hour, so let me do this. I'm going to take this down, and Al, let's put our hands together again one more time for Mr. Al Baur. Al, thank you again. This is the coolest stuff I've seen in a long time. The fact that it levitates, it follows the track on its own. You've got no wires, no strings. I mean, that's truly amazing. So thank you so much. And when you have more videos to showcase for us, I'd love to have you back in the future. So
I have a lot of videos.
Okay, well, I will reach out to you then. We'll see if we can bring those in. Maybe we could do lab updates or something like that.
Okay.
Okay.
And Malik, the next time I want you to help me because my English is not good enough.
Oh, I think
so. You can translate me some words from Hebrew to English.
Yes, I can act as a translator for you.
Oh, okay. Well, yeah, Mark could. Okay, well that would work then. Okay, so Mark.
You know, I'm original from Holland, so if you don't know Dutch, it's also okay.
Yeah, well, Mark can translate from Hebrew, so we can make that work.
Okay.
Wonderful. Okay, well, thank you so much. So I'm going to take everybody out except for Dr. Nathan Innen. And let me see, Nader, welcome, sir. Thank you. It is awesome to have you back. It is awesome to have you back. Let me apologize again for the technical issues. Today's been a little bit of chaos, but so you're going to be talking about the Meissner effect.